Very good morning, dear students. Here I just want to explain the concept equivalence of states. So the problem they may give like this. So they will give two types of finite automata, two different finite automata with a different type of states. Okay, and here they will ask us to check whether these two finite automata are equal or not by using the equivalence of states. Okay, so now I am going to explain this concept. So these are the diagrams they will give in the problem, and while we are writing the solution, once again we need to redraw the diagrams again. Okay, so here for the first diagram we need to list out what are the final states and the non-final states. Here so coming to this diagram, here the final state is Q1, you already know that. So which is indicated by using the front arrow mark. So that one will be the initial state, and which is denoted by using the double circle will be denoted as the final state. Okay, so here if you want to write the non-final states, you just remember final state means this one, and the remaining all states which are not final are the non-final state. Okay, so this is final state and the remaining states all are comes under the non-final state, that is nothing but Q naught here. Okay, so coming to this diagram, final state is P here and non-final states. Except final state, we will write all the remaining states. Here A and C, these are the non-final state. And here we will do the comparison. We will apply the equivalence concept here by using in terms of the transition table. You already know that transition table. So like the columns, we will here we will take the states, and this side we will take the inputs. Horizontally we will consider the inputs, and vertically we will take the states. Here in these diagrams, both the diagrams here same input we are having 0 1. If we are having AB means we will take AB here. Okay, and coming to the states, here we will start taking the combination of the states. From this diagram, what is the initial state here? Here the initial state is Q naught for the first finite automata. Here coming to this diagram, the initial state is A. So initially we will take the combination of two initial states of the finite automatas. Okay, so now Q naught on 0 means in this diagram Q naught on 0, it is going to Q naught, and A on 0 in this diagram, A on 0 it is going to A. Okay, in the same way Q naught on 1, Q naught on 1 it is going to Q1, A on 1, consider this one, A on 1 it is going to B. So after writing the first row, again we will check for the any new state combination. We already know that while we are converting from NFA to DFA conversion, we have done this. Okay, in the same concept Q naught A and Q naught A. Here new combination we got is Q1 comma B. We will repeat it until we left with no new state found. Q1 on 0. Here Q1 on 0 going to Q1, and B on 0. B on 0 it goes to B. Next Q1 on 1. Q1 on 1 it goes to Q naught, and B on 1. B on 1 it is going to C. Okay, so again in this row any new state Q1 B, it is already there. So this is the new state again, so that's why take it out. Q naught C, we will write the transitions for this new state now again. Q naught on 0, Q naught on 0 goes to Q naught. C on 0, C on 0 it is going to C. Again Q naught on 1, Q naught on 1 it goes to Q1. C on 1, C on 1 it goes to B. And once again check Q naught C, it is already there. q1b, it is already there. So now we didn't left with any new states. If you found any new states, again we will bring it out and we will write the transition for them also. Okay, so after completing up to here, then we need to check. Here we are having 6 different pairs, right? In these 6 different pairs, so it should be a combination of only the final states, otherwise only the non-final states. For example, if we consider here q naught a, here q naught is a non-final state and a is also a non-final state. q1b, q1 is a final state and b is also a final state, means in this pair it should be either final states, both the states should be final states, otherwise the non-final state, but there should not be a combination of one final state and non-final state. Okay, so if you got like this, then these two finite automata are equivalent. We can give the conclusion like that. But if you got any pair, so with one final state and one non-final state, then those finite automata are not equal. Simply ఇక్కడ ఉన్న పేర్లో 2 కూడా ఉంటే ఫైనల్ స్టేట్సే ఉండాలి, లేదంటే నాన్ ఫైనల్ స్టేట్సే ఉండాలి, బట్ వన్ ఫైనల్ స్టేట్ నాన్ ఫైనల్ స్టేట్ కాంబినేషన్ ఉండకూడదు. సో దట్ ఈస్ ద రీజన్ హియర్. క్యూ నాట్ సి, ఇఫ్ యూ కన్సిడర్ దిస్ వన్ ఆల్సో, క్యూ నాట్ సి నాన్ ఫైనల్ స్టేట్, సి ఈజ్ ఆల్సో ఏ నాన్ ఫైనల్ స్టేట్. q1b, q1 ఈజ్ ఏ ఫైనల్ స్టేట్, b ఈజ్ ఆల్సో ఏ ఫైనల్ స్టేట్. ఉంటే ఫైనల్ స్టేట్స్, లేదంటే నాన్ ఫైనల్ స్టేట్స్. ఓకే, సో బై యూజింగ్ దిస్ వీ కెన్ కన్క్లూడ్. ఓకే, therefore these two finite automata are equivalent. Okay, so very very important concept. By using the same equivalence concept, we can minimize the automata also. So in the next video I will explain it. Okay, so as of now, so they will give two finite automata diagrams, otherwise they will give the tables also. Okay, and you can know so what are the final states and non-final states by using the diagram, otherwise table. Okay, we will list on the final states and the non-final state for both the diagrams, and later we will take one transition table with the input and the state combinations. We will start taking from the initial state of both the finite automata, and we will write the transitions for them. If you find any new state, again we will write the transitions for that new state. So we will continue it until we left with all the existing states. Okay, so we will repeat it, that concept, and finally we need to check all the pairs whether they contains both the final states, otherwise both the non-final state. Okay, so if the pairs are like that, those are equivalent. Otherwise if you find any combination with one final state and the non-final state combination, then that is not equal. Okay, so thank you.